Welcome to the session on practicals in analog communication. Let us try to understand analog sampling and reconstruction experiment. This is the experimental board for analog sampling and reconstruction. This experimental board has four sections. First is audio generator section. Audio generator section will provide me modulating signal. I can adjust amplitude of modulating signal with the help of amplitude adjust potentiometer. I can adjust frequency of modulating signal with the help of frequency adjust potentiometer. Next section is getting pulse generator section. Getting pulse generator section will provide me sampling signal. I can adjust frequency of sampling signal with the help of frequency adjust potentiometer. I can adjust duty cycle of sampling signal with the help of pulse width adjust potentiometer. Third section is the modulator section, which gives out the sampled signals, and fourth section is the demodulator section, which records the modulating signal for me. Let us see the demonstration of this practical stepwise. First of all, we'll adjust message signal to 1 to 3 kHz frequency. As it is a sinusoidal signal, it will look like this. Next, I will adjust the sampling signal to the frequency 16 kHz and 50% duty cycle. The sampling signal will look like this. Now I will connect the message signal to the channel 1 of DSO. Now I will apply message signal to the first input of modulator block, and I will apply sampling signal to the second input of modulator block. At the first output of modulator block, I can observe the natural sample signal. The time domain version of natural sample signal will look like this. I can observe the spectrum of natural sample signal on the DSO. At the second output of modulator block, I can observe sample and hold signal. Its time domain version will look like this. I can also observe the spectrum on the DSO for sample and hold signal. At the third output of modulator block, I can observe flat top sample signal, its time domain version, and also I can see the spectrum on the DSO for flat top sampled signal. Now let's talk about spectrum of sampled signal. Here we have considered 16 kHz sampling frequency and 1 to 3 kHz modulating signal frequency. That is, we have followed Nyquist criteria. That is, Fs is greater than twice Fm. Thus, the frequency spectrum for the above sampled signal will look like this. Here we can observe the guard band in between the spectrum. Here, the spectrum around DC is the spectrum of message signal. With the use of simple low-pass filter, we can separate out the spectrum of message signal from the spectrum of sample signal. That is, with the use of simple low-pass filter in the demodulator block, we can demodulate the sampled signal. So let us apply the natural sampled signal to the input of demodulator block. At the output of demodulator block, we can observe the recovered modulating signal as shown. But if Fs is less than 2 Fm, that is for the case of undersampling, we can observe the overlapping in the spectrum of sampled signal. Hence, here, no filtering action will be able to separate out the spectrum of message signal from the spectrum of sampled signal. This phenomenon is called as aliasing. The probable questions on this experiment are: what is sampling? What is sampling theorem? What is natural sampling? What is fact of sampling? Sample and hold circuits, PWM, PPM, generation and detection methods of PM, PWM, and PPM techniques. Thank you.